Okay, the kinetic energy above me. The change in kinetic energy will be the work input plus the work of friction plus the work of P, which is parallel with the plane going down according to, excuse me, according to the free body diagram. Okay, now, that's going to equal, remember, the work input is positive, the frictional force and the frictional work and the P work will be negative, so that's going to translate to 460 joules. That's going to be the change in kinetic energy. Now, if I utilize this equation here and plug in 2 times the square root of the quantity, 2 KE divided by M, 2 times 460 divided by 60, square root of that quantity is going to equal 4. And that will be the velocity, the final velocity of the skier being pulled up the snow hill to go skiing. Okay? Now, so I put these values in here, so everything is done. Now, what I also did was I included the, you're going to have to do this, the efficiency. What's the efficiency of this apparatus, taking into account things that you're going to lose? There's going to be frictional losses here. Well, its efficiency is, one way to do it is work output divided by work input. And that's going to be 12,480 divided by 20,000. The efficiency is 0.624. Now, that's really not bad. If you look at combustion engines, which have extremely low efficiency, when you're stopped and your oil is used up or something and you have to get under the hood, isn't it hot under there? Well, that hotness is excess heat. So there's a tremendous amount of excess heat that the combustion engine gives off, and that's friction. That's, you know, the more heat it's given off, it's going to be very inefficient. But we'll talk about that when we talk about thermodynamics. We'll talk about that. Okay, now. Anyway, 0.624 is going to be the efficiency. Long problem. You did well. See you later, and Santana. Like